Hi, pre-calculus. We're going to talk about graphing logarithms today. So we've done this Desmos activity in class. If you were not here in class that day, the link is in the classwork and assignments folder in Schoology. And if you look at the top of the screen up here, this is the name of the activity. So if you wanted to do it, you could do it yourself. And if you want to be able to follow along with what we're doing. Sorry, I just stopped sharing my screen because I had this brief moment of thinking, wait, did I hit record? All right, so the first screen talks about, okay, what's the relationship between these two graphs? Because we're going to be graphing logarithms. Logarithms are the inverse of exponential functions. So this red one is a squared and this is a square root. So these are, we know, are inverses of each other. Remember, we know that the x and the y coordinates are interchanged, the reflections of each other over the line, y equals x, or y equals x. So here's another one. These are inverses of each other. If we trace this, we can see the x and the y coordinates are inverses or reflections of each other, right? And they reflect over the line y equals x. Okay, so we're going to use that same idea, that same relationship, but with logarithms. So here, this is the exponential function of x equals 10 to the x. So first it asks us to just make a table here. So if I put in -2 here, it would be 1 or 10 to the negative second, which would be 1 over 10 to the positive second, which is 1/100th. And then this would be 1 over 10 to the first, or 1/10th. Okay, and 10 to the 0 is 1, 10 to the first is 10, 10 to the second is 100. The idea is we would use these all these points here to graph our inverse. And so I want to interchange the x and the y. So I would plot 1/100th, -2. So 1/100th is practically 0, but down to -2. So I'm just going to get as down as I can. And then 1/10th, -1. So again, just really close to 0. I know that's not quite 1/10th, but 0, 1, and then I would plot 10, 1, and I'm not going to fit to 102, but you can see that it's growing, right? It's increasing, but very slowly. And then here, it's leveling off at the y-axis. So I'm going to do my best to sketch this. I know it's not really easy to do it, but okay. So, and you see it's a reflection of this over the line y equals x. So if I were to kind of sketch that line in, I'm not doing a great job of, but it's a reflection over that line. And because exponentials level off at the y-axis, or the x-axis rather, then logarithms are going to level off at the y-axis. So this is our parent function for a logarithm right here. All right, so here, if now we were to graph if it was 2 to the x and e to the x, and see what happens when we change this. It was the log base 10 of x. Now what if it was 2 to the x? So this would be 1/4. This would be 1/2. This would be 1. This would be 2. This would be 4. And if I graph that, I'm going to do a different color here. If I would graph that, so it's still starting, like it's still going to be leveling off here. This is still going to go through 1, 0, but now it's going to go through 2, 1. So it's just going to be kind of steeper, right, when I change that base to 2. When I change my base to e, remember e is at number 2.71828. All right, so I know these are going to be, this is just going to be 1 over e to the second, right? This, and it gives me my decimal. This is going to be 1 over just e. This is going to be 1, right? 19 to the 0 power 1. This is going to be just e. This is going to be e to the second, right? And then if I plot these points, oopsie, and they just, here they are right here. If I plot these points, you can see it just got a little bit steeper. Okay, so changing the base, that's the effect it's going to have. So now we're going to talk about if we transform logarithms. So we've got, this is just our general form over here, and we have all these parameters here on the left. So the h, see the h is going to shift it left or right, just like h's usually do. Right, so it's going to basically move our vertical asymptote. The k is going to move it up or down. Okay, the a is going to be that stretch, vertical stretch. If it's negative, it's going to flip it over, right? Now B, usually we'll do like a horizontal. It's a little different with a log. It still kind of seems like that. It looks like it's moving up or down, like stretching, right? But remember, you can't have a base that's 0 or negative. It just disappears, right? Because you can't have a base. We talked about that when we talked about anything that's logarithmic, the base has to be bigger than 0. All right, so now let's get into graphing these. So to graph these, you might be like, okay, well, what am I even supposed to be graphing? The graphs, the equations come from number 95 in the book. So for part A, the equation is y equals 5 times the log base 3 of x. And so what I'm going to do is I'm going to kind of think of what would the log base 3 of x look like, and then I know I have a vertical stretch. So what you want to do is you want to kind of make a little table and sort of think about what would that look like. So log base 3 of x is my y value here. Now, if I usually I just kind of pick numbers here, right? Pick numbers for x and plug them in. But if I just pick like, I don't know, 1, 2, 3, like if I put 2 here and I think log base or 3 of what is 2, that's not something I can easily think of off the top of my head. So what I usually do for these is I actually think my y values first because they're easier in my brain to think of. And then that gives me the x value because that log is the inverse of the exponential. So I'm going to start by picking y equal to 0. So I have log base 3 of what equals 0. So in my head, I'm thinking 3 to the 0 power is my x value. Well, anything to the 0 power is 1. So I can plot the point 1, 0. And then I'm going to do I'm going to say, I'm going to let y equal 1. I'm going to think log base 3 of what is 1. So that means 3 to the first is my x value. So 3. So really, if I just have those couple of points, and I'm just going to do this dashed. If I just have those couple of points, this right here is kind of like my parent function for the log base 3. And I know at 9, it would be at 2, right? If I wanted to be that particular, right? But this is 5 times that. So then what I'm going to do is I'm going to take these couple of key points. Let me change my color here. I'm going to take these couple of key points, and I know that they have to be multiplied by, the y values have to be multiplied by 5. So 0 times 5 is just 0. Okay, so that's going to stay 0. Let's see, how about purple? Okay, so this is going to stay 0. 1 times 5 is 5. So instead of this being at 3, 1, it's going to be 3, 5. But then the shape is still going to level off this x-axis. But this, right, when I do this right here, it kind of gives me an idea of my curve. And I know it's hard in decimals to draw this, and it shouldn't be crossing the x-axis. And if I click check it, and I'm pretty close, right? It should kind of be a little bit steeper. Maybe if I'd taken my 9 and multiply that by 5, I guess I would have known it would have been up here at 10. It would have been a little bit more accurate, more like that. That's better. Okay, so if I just get a couple of points so that I can get that curvature, you can't just like fling in a graph. All right, so now for this next one, for part B, our equation is y equals log base 0.5 of x minus 2. So when I look at this, I see that it's minus 2. I know everything's going to get shifted down. I'm going to start like I did with the last one. I'm going to graph the kind of the parent function for this, and then I'm going to shift everything down. So I'm going to have my x, and then my y is the log base 0.5 of x. All right, and again, I'm going to pick my y values first. So I'm going to think 0.5 to the 0 is 1. Okay, that's always going to be the case. So I'm going to have a 1 there. And then I'm going to pick y is 1. So then I'm thinking 0.5 to the first is a half, right? So this is a half. I could go one more if I wanted and put 2 here. Do 0.5 to the second is 1/4, 0.25. So if I plot these points, so 0.5 and 1 would be here-ish, and then 0.25 and 2 would be here-ish. So the parent function would be kind of coming down here and curving. This one would be curving down. All right, that base of the half is making it decreasing instead of increasing, but this says -2. So then what I want to do is I want to take my kind of key points here, like this half, I want to move this down 2, I want to move this down 2, and then my graph would be coming through this couple. Let's see, how did I, close-ish, right? Okay, it's, you're not gonna, if I did more points, then yeah, I could get it to go out more, but so that's fine though. All right, so let's look at, I got a couple more here. So let's look at C. This one is y equals the natural log of x minus 3. So I know in my brain that this means it's going to go to the right 3. When I make my table, I'm just going to make my table on the natural log of x. Okay, I'm not going to plug it in with this -3, subtract the 3. I'm just going to figure out like kind of the parent function for what I have here with that base, and then I'm going to move it to the right 3. So remember, natural log is a log with a base of e. So I'm going to put 0 in for y. E to the 0 is 1. And then I'm going to put 1 in. And I have e to the first is just e, which is like 2.71828 and so on. So this I'm going to just estimate to like here-ish. All right, so my graph of my parent function goes kind of like this, but it's moving to the right 3. Excuse me. So it's moving to the right 3. So what I want to do, what I like to do is I like to draw in, I have a new vertical asymptote. My asymptote is not the y-axis anymore. Now it's here. So now when I take this 0.10 and I move it to the right 3, it's 1 to the right of my new asymptote, right? And then this was 2.78 here. Or I could just take that point and go 3 to the right. And so then when I go to graph my transformed one, it's like the same thing, but it's kind of going like this. I know this isn't going to be very, oh, that was closer than I thought. It's hard to make this pen be super fine and accurate there. All right, so then for part D here, our equation is y equals negative log of 4, or log base 4 of x. Okay, this negative is going to reflect over the x-axis. So I'm first going to just make that table again with just the log base 4 of x. And then once I have it, then I'm going to flip it. Now, if you're in your head like, oh, I can do that at the same time in my head, then that's fine. You don't have to do 2 different graphs. As long as in your head, what you're doing is you're thinking of this and then doing the transformation. Or sometimes I'll say, oh, I'm moving to the right, and I'll kind of draw my asymptote in first. And then when I do this, I'm like, oh, I'm just going to plot it from like kind of my new axis instead of my old axis. All right, so I just like to start with 0, right? Because this would be 4 to the 0. Well, that's just 1. And if I start with 1, it's 4 to the first is 4. So my parent function would be like going through here. Okay, but this negative is going to flip it. So this stays where it's at, but this flips over here, and now it's coming down. How did I do? Yeah, can't get it just perfect, but pretty close. All right, got one more. This one is y equals the natural log of x plus 4 plus 1. So here, this is going to go left 4. This is going to go up 1. And I like to draw in, like, where are my new asymptotes going to be? That helps me to see things. Make sure everything is approaching where it should approach. Okay, I'm going to make my table. So I have my x, and I have, what is this? The natural log again. Really, we just did this, right? We did a natural log, and this was a 0 and 1, and this was a 1 and a 2.718. And so I could think, well, normally it would be, you know, here and like here-ish, right? Now all these points have to go to the left 4 and up 1, right? So I have 2 ways to do this. One way, oops, this keeps going up. Okay, one way to do it was to plot these, and then for each of these points say, all right, I have to now go to the left 4 and I have to go up 1. and then plot my new point. Right? And I can take this 2.718, whatever, and go to the left 4 and up 1. The other thing you can do is if you've drawn your new axes, then I could just plot these points from this new transformed axis. So from here, I could go 1, 0, and then I could go 1, 2.78 up 1, and then it approaches that asymptote. I draw the asymptote in so that I make sure it really is approaching where it should be approaching. And then check it, pretty close. All right, so that takes care of 524 graphing logarithmic functions.